Hi again, welcome to the video in which we develop important relationships with trig ratios. Having defined the ratios, we now need to use them, so we need some tools. These relationships complement or supplement those results for angles of any magnitude developed in a separate video. The results need to be remembered too, and they will be used in many contexts during your course. For our work, we of course need a triangle. Wouldn't be trig without a triangle. So I've marked in one angle as x, and now we can look at our basic ratios, trig ratios and functions. So sine of the angle of x is equal to the opposite over the hypotenuse, b over a. Cos is equal to the adjacent over the hypotenuse, c over a. And tan, of course, is opposite over adjacent. Now we also define reciprocal relationships, in other words 1 over the trig ratio, because sometimes they're very handy in our analyses. So we call cosec the value of 1 over sine x. We call sec the value of 1 over cosine of x, and cot is the value of 1 over tan x. So they're the reciprocal relationships. If you get into trouble at some stage and you can't remember which is which, go for the third letter. So in cosec we've got S for the third letter, therefore it's a 1 over sine. C in sec is 1 over cos, and the T for in cot is 1 over tan. Quick way to remember it. Now we come to the complementary angles. Now the complementary angle, of course, you know that, is where two angles add up to 90 degrees. So in our triangle, the bottom angle was x, we've got a right angle in there, so the other angle at the top must be 90 minus x. So it's the complementary angle. So if we take the sine of that particular angle, we have opposite c over hypotenuse a. If we go to cos of the 90 minus x, we have the adjacent b over the hypotenuse a, and the tan, we have the opposite, which is c, over the adjacent, which is b. Now, have a look at this. The sine x is equal to cos of 90 minus x in terms of its ratio. So that's interesting. We can therefore write cos 90 minus x is equal to sine x. Go do the next one. Cos ratio is c over a, and so too is the sine 90 minus x ratio. So we've got another equivalence. Sine 90 minus x is equal to cos x. A little bit more difficult with the tan because it's not quite the same. However, if you look, it's the upside down ratio. So tan of 90 minus x is the same as 1 over tan x. And just now we defined cot x to be 1 over tan. So there's our three complementary angle ratios. They're a little bit more popular now than they used to be. Now a special ratio which you're going to use a fair bit. If we divided sine x by cos x, that'd be the same as dividing b over a by c over a. We divide by a fraction, we can change that to a multiplication sign and invert. So we've got b over a times a over c, the a's cancel, leaving us with b over c, which is our definition of the tangent ratio. So therefore we've got sine x over cos x, which is tan x. So whenever you see a tan, you can write sine x over cos x, and you'll do that a fair bit. The next set of relationships are called the Pythagorean relationships after the grand old man Pythagoras himself. So if we take our basic ratios and we clear the fractions, we have b is equal to a sine x, c is equal to a cos x, and b is equal to c tan x if we wanted that. Now Pythagoras, as you know, used to love squaring things, and he saw a triangle like this and he said, "You beauty, I've got a squared is equal to b squared plus c squared." So we do that again, and then we substitute for b and c, squaring each of them. So we've now got a squared is equal to a squared sine squared x plus a squared cos squared x. Take out a common factor of a squared, and we're left with a squared is equal to sine squared x plus cos squared x is equal to a squared. But the a squares cancel, and so we can now prove that sine squared plus cos squared is equal to 1. So I'll write that again up the top, sine squared x plus cos squared x is equal to 1. And now I'm going to divide each of those terms by sine squared. So I've got sine squared over sine squared, which is 1. Cos squared over sine squared, we now know that is cot squared. And the 1 over sine squared from our reciprocal relationships we know is cosec squared x. So 1 plus cot squared is equal to cosec squared. Now I'm going back to our sine squared plus cos squared, and I'm now going to divide by cos squared instead of sine squared. So I've got sine squared over cos squared. We know that sine over cos is tan, so tan squared plus cos squared over cos squared is 1 equals 1 over cos squared. Our reciprocal relationship was sec squared. So here's another, our third Pythagorean relationship. So to summarise our work in this video, we've got our basic relationships. We then defined our reciprocal relationships as being the 1 over relationship, so it turned everything upside down, but we had to have a special name. We then had the results for the complementary angles, so the 90 minus x results. We then developed our special result, allowing us to replace tan x by writing sin x over cos x. And then we developed our 3 Pythagorean results, including the squares of each of the main ratios. On this page I have summarised these very important trig relationships, all of which we use frequently in various contexts. You need to record these results and remember them through applying and feeling what they are saying. To help you in this regard, go to the Trig Identities Test Yourself 1 on my website, drjsmaths.com. You might also look at how to study and prepare in maths. Check the second last entry in the main menu, or look under S for study in the index. The results we have developed in this video go together with the angles of any magnitude discussed in a separate video. Thanks for watching this video. Hit the like button and subscribe if you haven't already, so you get notified of new videos as they come up. Good luck. See you amongst the identities.